All right, so the first, get rid of this. First thing we're going to do is the scientific notation review. So we've already done this. You actually even had a few of these on the final. So this is just literally to remind you guys kind of what it's, because we're gonna use some numbers that have exponents. So they're basically gonna be in scientific notation. I am not gonna reteach this. I'm just giving you this so you have it in case you need to remind yourself. And then basically all I want to do is just do some of the examples here, run through them just to make sure we know what we're doing, okay? So in scientific notation, if we're going to put something into scientific notation, we want the beginning part to be the number between 1 and 10, and the second part is the something to the power of 10. Remember Lars, left add, right subtract. So down here, if we look, if there is no decimal, that means the decimal is at the very end, like the decimal starts at the end of the number. So if there's no decimal down or put in, that means it's a whole number and the decimal's at the end. So the decimal will be here. So we're going to move this decimal from here to between the 4 and the 5, because that gives me 4.5. Okay, that's a number between 1 and less than 10. So 4.5. Then we do the times 10, and we moved it 1, 2, 3, 4, 5, 6, 7, 8 spots to the left. So left add. So if there's nothing there, it's going to be positive 8. Good on that? All right. Same thing with B, except in this case, we're going to move. So there is a decimal. So this is where the decimal starts. We've got to move it so the number is between 1 and less than 10. So we're going to move the number after the 8, between the 8 and the 0, after the 8. So it becomes 8.01 times 10. And then we got to count how many times we moved it. This is a little harder. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you move it to the right, when we're putting it into scientific notation, you subtract, it's going to be negative, so negative 10. How do we feel about that? Does that make sense? Everybody's good? Okay. So C, where are we going to move the decimal? Good, between the 4 and the 7. So it's 4.7205. We want all the numbers that were there before. Times 10. We moved it 2 to the left, so that becomes positive 2, like that. And what about D? Where are we going to move that decimal? Okay, between the 9 and the 6. Good. So we get 9.60 times 10. And we moved it 1, 2, 3, 4 to the right. So negative 4. Any questions on that? The next ones, we're going to put these into correct scientific notation. They're already in science, like some form of it, but it's not really correct because our beginning number is not between 1 and less than 10. So ignore the times 10 part to start off with. So we're just looking at this. No decimal means the decimal starts at the end. Where do we want to move the decimal? 2 and the 6. So our beginning part is going to be 2.67 times 10. Now, we moved it left, so with Lars, left add. So we moved it left 3 times, so we're going to add 3, but we've already got something here. So we're going to add 3 to what we already have. So 6 plus 3 gives us 10 to the 9th. Everybody okay with that logic? Zoom in a little bit here. All right. Next one, same type of idea. We're going to ignore the times 10 part, move the decimal, so it's going to be between the 3 and the 5. So we get 3.5 times 10, and then we moved it 3 to the right, so we're going to subtract. So we've got -3 minus 3. You got to be careful here. -3 minus 3 gives us -6. So far, so good. 76,000, decimal at the end, because there is no decimal, so we move it between the 7 and the 6, so we get 7.6 times 10. We move it 1, 2, 3, 4 to the left. So moving it left, we're going to add. So -8 plus 4 gives us -4. Okay, and then the last one, decimal here, we're going to move between the 3 and the 8. We get 3.84 times 10. We moved it 1, 2, 3, 4, 5, 6 to the right. So we're going to subtract 6. So again, kind of watch here. 3 minus 6 gives us a -3. All right, everybody feel, like I said, I know this is just review. We've kind of done it before. Any questions on this stuff? Okay. Let's look at the bottom. Taking it out of scientific notation is sort of the reverse. If the exponent is negative, move the decimal to the left. If the exponent is positive, move the decimal to the right. Basically, if your exponent is positive, you want your number to be bigger than 1. If your exponent is negative, you want your final number to be less than 1. Not negative, you want it to be less than 1. So 5.02, we're going to move, so we've got 5.02 times 10 to the 7. So we're going to move it 7 to the right. So 1, 2, and then 7 more. So we get 5, 0, 2. I'm sorry, not 7 more. 5 more, because we moved it twice already. So 5 more. So 0, 2, and then 5 zeros. If there's nothing there, you just put 0. So 1, 2, 3, 4, 5. Put commas in 3. So it's 50,200,000. Okay. If the exponent's negative, you're going to move it left. 7 total. So we had 1, 2, and then 5 more. So here, give myself a lot of room here. So that's when we're putting it into scientific notation. So when we're taking it out, it's kind of like the reverse. So -4, we're going to move it left 4 times. So 0. Now the easiest way for these is because you're going to move it 1 to get past the first number, and then so that's, now we're down to 3, so we got to move it 3 more times to the left, so it's 3 zeros. So when it's negative and you're taking it out, the easiest way is to put decimal point and then 1 fewer 0 than the exponent. So it's -4, so we're going to put 3 zeros and then whatever numbers were there. 9224. Okay. 4.609 times 10 to the second. What is that going to become? Move it 2 to the right, so 460.9. 7.7 times 10 to the -6. So negative, so if we're taking it out, we're going to do 0 point, so decimal point. Then how many zeros will we need after the decimal point? 5, good. 1, 2, 3, 4, 5, and then the rest of the stuff there. 7, 7. Okay. Questions? Okay.